Before we actually just start coding here, whatever, it's a good practice to just test if your assumptions are correct. So let's put in a print string saying hello. So we are hoping that when the actor overlaps with the door, we get the hello trigger. So let's move to the door and nothing happens. You may ask why. Because there is a difference between collision and overlap. Overlap assumes objects go through each other and essentially overlap in a certain point. But collision stops this from happening. So what we do, we go back to the blueprint and take a look at the viewport. As this door is a solid object, we cannot just go through it to overlap with our player character. By the way, I just noticed the door is reversed. So let's just... This is embarrassing, but let's just... My apologies. Yes, rotate it in the right direction. I don't know, maybe there are some doors that have had on the left. I have never seen one so far. Other than double doors. Okay, so let's go back to the door. And here, we need to add a collision box. We will not be using this box for collision specifically. This is just a box to trigger an event. So let's scale it to the size we want, where it will trigger if the player character hits it. You can just make it like this, and I don't want this event to trigger after we entered the room. I want it to remain open. So let's just do like this. So I don't have to worry about the other side of the door. So logically speaking, now the purpose of this is when the player character, overlap with this invisible box, the door will open. But before we can do this, let's remove this and click on the box that we created. This is the box we have created. And on the right side, down on the details panel, you will see we have events. These are made automatically by Unreal to make your life easier, so you can just save time and just click what you need. So in our case, we need on component begin overlap. So you may ask, what do you mean by component? And that component is everything inside the actor. This blueprint itself is acting as actor. The static mesh component here is the core, essentially the root component of the actor. It cannot be deleted, it cannot be removed, it can be changed, but ideally the root of the component is what is everything is centered around. And the door part itself is part of the door, and door frame is actually the root of the scene. So this internal part of the door is just a attached static mesh component. And same goes for the box. We could add infinite amount of, well, not really infinite because of computational reasons, but a lot of additional components, but in this case we don't need them. And we can see here it says on component begin overlap, and at the very end you can see there's box. This is just the name of the collision we have created. So if we change the name to, let's say, ZZZ, you will get this ZZZ. So I like the box better, made more sense. We put this now to here, print string, and to test if this will actually trigger the overlap event. So we go back to the level, press play, go back to the box. Oh, we have the hello on top left. We have, as you can see, this triggers multiple times. Every time we enter the overlap. So let's go back to the blueprint. Now we confirmed this actually works as we want. We could add a lot of limits on what can specifically trigger this door opening, or how many times it can be opened, closed, or do we want to open it and close automatically afterwards. We can do every single one of these scenarios, but we are going to keep it simple. We are just going to open the door when we approach the door. So now, how would you say the door is supposed to open here? For the door to open, let's say we want this door to open, let's say inwards. You would just need to rotate this at the angle of 90. Maybe realistically it would be like something like 80, but I prefer 90 degrees. So what we can do is we can go here, drag this SM door node here. By the way, this SM door node now is a variable. Act here in the event graph. And before we move on, let me explain what variables are. Variables are the most basic part of the coding process, not only in Unreal but also in C++, C#, and everything else. Variables are essentially, you could say, placeholders or content of information that are used to code. For example, like in the, let's say, math, you would be like x plus y, or x multiplied by y equals z. This is the same logic. This is our x, this is our y, the other one will be our z. And when we code, we don't have to every single time somehow reference or put all the information associated with the object. We can just put this as a handle or a tag, or however it is you want to accept it, easier for you to understand. This is now our door. So SM door here. This is a reference to this SM door. And this SM door is now referenced here in the blueprint. Now, what we can do with this? Before, we need to understand what we are trying to do. We want to rotate this door in 90 degrees in the z-axis. Minus 90 degrees to be more specific, in the z-axis. How can we do it? So, for this we need to get a timeline. So, timeline, and add it here. Now, you may ask, what is a timeline? Essentially, the over time triggers, like events, the door, we don't want the door suddenly snap open. So if we, for example, take this SM door and let's say take a node from it and set rotation, and put in, like, set relative rotation to minus 90 on event trigger, it will instantly open. But this is not the look we want. You wouldn't want to have this kind of sudden trigger on your door. So now how do we fix this? So we want this door to open over time. So over, let's say, 2 seconds. And the way we do is with a timeline. So we have this node which is set relative rotation of the component it is attached to. In this case is SM door. This door is the target for this function. And what this function does is rotates object in whatever value we put in. We can make it bigger for the additional nodes, but it's not relevant now. So let's take a look at what we are modifying here. We are modifying z-axis. We don't really care about x and y. So what we can do, we can right click and split this struct pin. So what we did is essentially split this vector value of rotation into 3 float values, which this automatically converts back to rotation. The reason why we are doing this way is because we are only modifying one specific value out of 3, so we don't need to plug in 3 values. We take this execution pin and put it into play. The reason why I put it into play and not play from start is because we want this to happen essentially only once. This will play, it will finish, and it will stay finished. If we put it into play from the start, it will begin, every time this will trigger, this timeline would begin from the start. But we don't want this, so we are just going to have it on play. And now we have this SM door, set relative location, and we need to update this set relative location with a value we will get from the timeline. So we need to decide what value we are going to output from this into this relative rotation. We double click on the timeline and this will open like this, and we click on this plus track. Because we are modifying only one value, we don't really need a vector track which contains 3 values. You can just use a simple add float track. So we have this track, and let's rename it z axis. And here we need to add a time. So length of the time is currently 5 seconds. Let's test this with 5 seconds. So, and the value, we don't have any values here. It's just a straight line, nothing happening. So the way we do it, we shift click once to add a node. So the beginning is going to be 0. It's no rotation. So we put it in the 0. The value also will be 0. And let's add a second node, which will be at 5 marker. Let's zoom out. It's going to be at 5 seconds. Can put manually time, and the value will be 90. Minus 90, because we are going a negative number. So this is a very straight up graph from 0 to minus 90 in 5 seconds. And let's compile it, go back to event graph, and now we have this z-axis from the timeline. It's an output of the values that this function is going to give us every second, not only every second, like every frame that we will need to input into here. So now this z value that this set relative rotation function is responsible for is being updated by this timeline. So we compile this, save just in case, and go back to our level. Now when we trigger this, the door will slowly open, very, very slowly. And now we're here. If we have done not play, but play from the start for the trigger, and pressed go back to the testing, we would have this weird situation where, okay, this is opening, and I move out, and I come back, and okay, it's opening again. I come back, and okay, as you can see, this is at best a prank. At first, a malfunctioning automated door. So we don't want this. So we do this play. And you may think, what if I want to close the door? And it's a reasonable question. What if first time I go through the, if when I go inside I want it to open, and when I go outside I want it to close? It can be done. The way it can be done is quite easy. So we could add additional variables that say if it is true or not that we are inside or outside, etc., in case there are multiple exits from the building. In our case, we have only one entrance, so we are going to just keep it simple. If I entered from this point, and I need to also exit from this point, correct? And we are going to have the door remain open. Maybe we just want it to have some air. What we can do is we can add a node here called flip-flop. Flip-flop. What this node does is the first time this event is triggered, this will play from the start. And the second time this event is triggered, it will reverse from the end. Now let's test it and take a look. As you can see, this is triggering every single time the actor overlaps, and this is not what we want from our door. So what can we do to fix it? There are multiple ways to do this, as always. What we can do is add a very simple variable that says if the door is open at the moment, or if this animation stopped playing or not. So what we can do is we can create a variable which says is can open / close doors. It's a boolean value. So the boolean values are values which just say yes or no. So in this case, can we open the close and door boolean value? We want this to be yes when the animation has stopped playing. So how do we implement this? You can press B and click, which will create a branch node. So what branch does is you put this into branch and add this value to here. We want the default value of this to be true because door is usually closed. At the very start, we want this to trigger at least once. And if it is true, we want this to play. And if it is playing, we want it to be false, so it cannot trigger the second time. So what we do, before we move on to here, we create and we drag this and set open close door here and put the value of it to false. Create a copy of this, second one, and do the same. We want this to be false in both cases because this way this cannot trigger the second time. But we want it to close after it's finished already opening. So what we do this again. On finished, this will set this to true. And this will be the end of this line. Now let's test it this way. And let's go. Okay. This does not trigger again, as you can see. And when I trigger it again, it closes. So we can trigger this, go inside, and when we go outside, we will re-trigger it, and this will close again. Obviously, this is not the most ideal solution to this. You wouldn't want to have your door open and, oh, okay, I will go back and come back. And now the door is closing to your face. There are more reasonable ways to do this. We can add triggers on both sides of the door. for example. We can duplicate this and add another one here. This one will open when we come in. This will trigger and will close the door after we are inside, or vice versa. Or we can reverse them by using the combination of blueprints and or nodes. But this is good enough for what we are trying to achieve here. This is a very basic, non-optimized way of opening a door. And there are too many details to this simple function that is just all about opening this door. We could have done it in a much simpler way, but there would be less to explain, so we had to stick with this weird, overcomplicated solution. Now, this is how we opened the door and we got into inside. As you can see, this is thanks to the blueprints. The blueprints enable us to create functions the way we want. I could do this is just a simple door with opening and closing animation. We could do it multiple ways. We can have this door recognize this character and open this character only to this character. You could have, let's say, NPCs or non-playable characters in the game, and these characters may or may not trigger this door depending on the access levels they have. Maybe you want a specific character to go through this door, but others no. Maybe you need a specific item to do this. It all depends on how you want to do it and your creativity. While this is usually called just exposing the variable to the editor, essentially, this is not really the correct name of it. It is instance editable. You may ask, what does expose on spawn do? So, if we have an actor that spawns other actors into the level. So, for example, in this case, let's spawn actor from class and select the spawned actor as this specific same lamp. So now we have this lamp which we can spawn, right? And if we set this my apologies, we just need to put in a value here, and in this case I'm just going to skip the process and expose on spawn. As you notice, I added expose on. If I compile, well, this expose on spawn is not available. Let's say if I just select it, this will not show up here, even if I compile it. But if I put expose spawn, now suddenly I have this function. So this means I can create an actor that spawns a specific actor with the parameters I want. How is this useful, you may ask? Let's say you have a game where you shoot projectiles. Fire, ice, electric, I don't know, laser beam. The color is the only thing that's different between your projectiles. And this color is defined per actor upon spawn. Similar to what we have here. When they come into existence, they set their light color, etc. But if you want to set the light color for that projectile, upon spawn, specifically depending on the parameters, certain parameters you may have in your game, you can use this expose on spawn to have that option available to you when you expose it. And obviously, unless you need this, you leave this off. Okay,